Hello and welcome to another GCSE revision video, and in this video we're going to be looking at quadratic inequalities. In solving quadratic inequalities, our first job is to find the points where the curve touches the x-axis, that is to say, to find the zeros of the quadratic expression. Okay then, so to solve a quadratic inequality, the first thing we do is treat it like it was a quadratic equation. So we're looking for the zeros as if it was a quadratic equation. So we take the x squared is greater than 9, for example, and we're going to ignore the greater than sign and just pretend for a minute that it is actually an equal sign. And then we can rearrange it and solve as if it was x squared equals 9. And this gives us the solutions either x equals 3 or x equals negative 3. These are going to be the points where the quadratic equation x squared minus 9 equals 0 is satisfied. So now we have our solutions to the quadratic equation, we can split our number line into three segments. So we have where x is less than the smallest solution, where x is bigger than the largest solution, and where x is in between the two solutions. So for our specific example of x squared is greater than 9, the solution to x squared is equal to 9 is x equals 3 or x equals negative 3. So we need to consider the values for x where x is less than negative 3, where x is between negative 3 and 3, and where x is greater than 3. So we know that if x is equal to 3 or x is equal to negative 3, then x squared is going to be equal to 9. If x is less than negative 3, then x squared is going to be greater than 9. We can test that statement simply by saying, let's try x is less than, or x is equal to negative 4. Negative 4 times negative 4 is positive 16, which is greater than 9. So that statement is true. If x is less than negative 3, then x squared is greater than 9. Now if x is between negative 3 and 3, then x squared is going to be less than 9. Again, we can test that statement simply by picking a number that's between negative 3 and 3. Let's take, for example, negative 2. Negative 2 times negative 2 is positive 4, which is less than 9. Or we could have taken positive 2 and said, well, positive 2 times positive 2 is positive 4, which again is less than 9. And if x is greater than 3, then x squared is going to be greater than 9. Again, we can test that statement. We can pick something like x is equal to 4. Well, 4 times 4 is 16, which is bigger than 9. So our solutions to x squared is greater than 9 is x is less than negative 3 or x is greater than 3. Okay, well, so much for the theory. Let's have a go at putting that into practice. Let's try something like x squared plus 5x plus 6. Let's say that's bigger than 0. Okay, so our first job is to find the 0 points. So that's going to happen when x squared plus 5x plus 6 is equal to 0. So we can just factorise these two numbers that multiply together to give 6 and add together to give 5. That's going to be 3 and 2. So that's x plus 3 x plus 2 is equal to 0. So our zeros are x equals negative 3 and x equals negative 2. So we want to ask ourselves what's going to happen if x is less than negative 3, if x is greater than negative 2, or if x is in between the negative 3 and negative 2. So if x is less than negative 3, well, if x is equal to negative 3, then this whole equation goes to 0. But if x is equal to, say, -4, which is less than -3, then we've got 4 squared. Well, actually, we can use the other equation here. This would probably be easier to look at. So 4 plus 3 is 7. 4 plus 2 is 6. 6 times 7 is 28, which is bigger than 0. So then x squared plus 5x plus 6 is greater than 0. And if x is greater than -2, again, negative, let's say something like x is equal to, say, -1, which is greater than -2. So, well, actually, any number like 0 is bigger than -2. Let's say x is equal to 0. That just makes life simple. Then this first term goes, x plus 3 becomes 3, x plus 2 becomes 2. 3 times 2 is 6, which is bigger than 0. So x squared plus 5x plus 6 is bigger than 0. And if x is in between, so if x is less than -3, actually, that's not the best way to write that. So if -2 is less than x and x is less than -3, so x is between -2 and 3, then x squared plus 5x plus 6. Well, let's have a look at our equation. So let's take something like -2.5. -2.5 plus 3 is going to be positive 0.5, and -2.5 plus 2 is going to be negative 0.5. So that's a negative times a positive is a negative, so this is going to be less than 0. It's actually going to be negative 0.25, but that doesn't matter. The fact is it's less than 0. So if x is between -2 and -3, then the top statement is false. So our solution set is x is less than -3, or x is greater than -2, both of which will satisfy the inequality x squared plus 5x plus 6 is greater than 0. Okay, let's try another one. Okay, let's try this one. Let's try something like 2x squared plus 2x plus 3 is greater than 0. Okay, well, I can't immediately think of any factors of 2 times 3, which is 6, that will add up to 2. So, in fact, just off the top of my head, I'm not sure there are any values for 2x squared plus 2x plus 3 that will equal 0, but we'll check using the quadratic formula's discriminant. So we've got our b squared, which is 4, minus, and now 4 times a times c is 4 times 2 times 3. Well, obviously 4 times 2 times 3 is going to be bigger than 4, so our discriminant is going to be negative. And if our discriminant is negative, then there are no solutions to 2x squared plus 2x plus 3 is equal to 0. So that means that either all solutions are valid or no solutions are valid. So 2x squared plus 2x plus 3 is not equal to 0, is never going to be equal to 0 for any real value for x. So if any value for x is great, gives the value 2x squared plus 2x plus 3 greater than 0, then it's true for all values for x. And if any value for x gives 2x squared plus 2x plus 3 is less than 0, then this statement above is false for all values for x. So let's try x equals 0. 2 times 0 squared is 0, plus 2 times 0 is 0, plus 3 is 3, which is bigger than 0. So therefore, all real values for x, I don't know if you've come across this terminology, but that means that every single value for x will satisfy the equation, the inequality 2x squared plus 2x plus 3 is greater than 0. Okay, let's try one more example. Let's try something like x squared plus 2x plus 1 is greater than 0. Okay, well, we might recognise this one as a perfect square, because if we take the square root of 1, which is 1, and then double it, we get this middle number here. So if this is a perfect square, this is just x plus 1 squared, which is greater than 0. So if we try to solve the equation x plus 1 squared is equal to 0, we get x is equal to negative 1. That's the only solution to x plus 1 squared is equal to 0. So all we need to do is ask ourselves, what happens if x is less than negative 1? Then x squared plus 2x plus 1. We could actually just plug the numbers in, or if we know our quadratics, we know that because this x squared term is positive, it's going to open out at the top, something like this. And we know it touches the x-axis at just one point at x equals 1. So every number less than 1, this is going to be bigger than 0, and every number greater than 1, this is going to be bigger than 0, and it's only at x equals 1 that it's actually equal to 0. So we might actually just know that from our quadratics. If not, we can just plug the numbers in. We can take something like, let's try something like negative 2 and plug that in. Negative 2 plus 1 is negative 1. Negative 1 squared is 1, which is bigger than 0. So if x is less than negative 1, x squared plus 2x plus 1 is going to be bigger than 0. And again, if x is bigger than minus 1, then x squared plus 2x plus 1 is also going to be bigger than 0, and we can check that just by taking something like, say, x equals 0, for example, which is bigger than negative 1. 0 plus 1 is 1, 1 squared is 1, which is bigger than 0. So when we come to do our solutions, we can say something like x is less than negative 1, or x is greater than 1. And that's not the same thing as saying x is an element of all real numbers, because remember, the only value, sorry, that should be x is greater than negative 1. The only value that's not allowed is x is equal to negative 1, because that doesn't satisfy the inequality x squared plus 2x plus 1 is greater than 0, because if x was negative 1, then x squared plus 2x plus 1 would be equal to 0. Okay, I hope that was helpful. Why don't you have a go at practicing some quadratic inequalities for yourself? I'd like to wish you all the best with your revision, all the best with your exams, and I'll see you in another video.